What's the smallest thing that you can see? A grain of salt? The tip of a hair? A speck of dust? Now imagine something 1,000 times smaller. It's difficult, right? It's hard to imagine something that you can see. But there's a whole world down there. If you go 1 billion times smaller than a meter, you've just entered the nano world. Hello, I am Laia Delgado Callico, and today I'm going to tell you about the curious case of melting at the nanoscale. At the nano world, everything is at a very, very small scale, the nanoscale. At this size, we find groups of few atoms that are called nanoparticles. A material at the nanoscale behaves different and has different properties than the same material at a normal size. One of the most interesting characteristics of the nano world is the melting temperature. The melting temperature is the temperature at which a material goes from solid to liquid. For example, water starts melting at 0 degrees Celsius, and it doesn't matter if you have a big iceberg, an ice cube, or even something smaller like a snowflake. They will all start melting when the temperature goes above 0 degrees Celsius, because that's the melting temperature of water, and the melting temperature does not depend on the amount of water that you have, except for at the nanoscale. At the nanoscale, nanoparticles melt at a lower temperature than the standard melting temperature of their material. We know that the melting temperature of gold is 1064 degrees Celsius. If I heat this earring up to 1064 degrees, it will melt, but 1064 degrees is a very high temperature. Take into account that the maximum temperature that a home oven can reach is 300 degrees Celsius. You need an industrial oven to reach such a high temperature to melt gold. But a gold nanoparticle can melt at a much lower temperature. It can melt at a temperature 500 degrees lower. But why? What makes nanoparticles have such a low melting temperature? Let's explain this using rice. I am going to build 2 nanoparticles using grains of rice. I'll build one small and a larger one using more grains of rice. I have here 2 balls. These represent 2 nanoparticles, and every grain of rice represents an atom. For reference, if this ball of rice had the size of a nanoparticle, I would be as big as the Earth. Then I'll paint the grains of rice that are in the outside of each ball. When I'm finished, I'll carefully take apart each grain of rice, separating the painted ones from the white ones. This way, I'll have on one side the grains of rice that were on the surface of the nanoparticle and are now painted in pink, and on the other side, the grains of rice that were inside the nanoparticle and remain white. Now, I'll count how many of each I have for both nanoparticles, the small one and the big one. The small nanoparticle has 60% of its atoms in the surface, while for the big one, it's 53%. The small nanoparticle has a larger proportion of atoms in the surface compared to the big one. The smaller the nanoparticle, the higher the proportion of its atoms that are in the surface. These atoms that are in the surface are only attached to the nanoparticle by one side, while an atom that is inside the nanoparticle is completely surrounded by other atoms. The atom that is in the surface only needs to break this connection and it will be able to move. But an atom that is inside the nanoparticle cannot move. When we heat the nanoparticle, we are giving energy to the atoms. This energy is used to break the bonds that keep the atoms together. The atoms that are on the outside need less energy to break away. This way, they will start melting first. If you have most of the atoms in the outside, the particle will melt more easily. You need less energy, therefore you need a lower temperature. So, small nanoparticles have a high proportion of atoms in the outside. These require less energy to melt, and in consequence, the nanoparticle will have a lower melting temperature. Although we don't see the nanoparticles, these are very common and have many applications in our daily lives. For example, there are nanoparticles in the engine of a car that help reduce its pollutant emissions. The processes that take place inside the engine of a car happen at high temperatures. So, knowing exactly at what temperature these nanoparticles will melt is extremely important to be able to use them. Next time you're in your car, Remember that there are nanoparticles right there helping to reduce pollution.